students. Welcome back to our final segment in our notes for wind and water energy. As you know, we have been talking about renewable energy sources this week. We started off learning a little bit about wind energy. Yesterday, we learned a bit about water energy. And I only had a few more that I wanted to mention to you briefly before moving on to the next segment of our notes. So why don't we get there now? There are some additional sources of renewable energy as well. And again, I'll be linking you to some videos to watch regarding these other energy sources. One of which is tidal power. As you know from your study of earth science years ago, the earth is influenced by the moon as it orbits around the earth every day. And as a result, the influence of the moon's gravity causes the oceans to rise and fall twice a day, 2 rises and 2 falls. These are called tides. And taking advantage of those changes in tides can result in the production of energy as well. Remember, you don't have to pay for gravity, whether it's the Earth's gravity or the moon's gravity. So tapping into tidal power is really tapping into the free source of gravitational energy from the moon, even though it's 250,000 miles away from us. How cool is that? Now, there are certain places that are much more suited to tidal power than other places. Obviously, you wouldn't use tidal power on the top of a mountain. So tidal power is fairly limited to ocean environments. In addition, based on the shape of coastlines, some coastal areas are influenced by the tides much more dramatically than other locations. I think the greatest difference in tides on planet Earth is near the Bay of Fundy in Canada, in eastern Canada. And I forget the value. I might have a video here on it, but the change in tide from high to low tide is incredibly enormous. In fact, the tide is so dramatic that when the tide goes in, when the tide rises and it increases the water level upstream in the major rivers, it actually causes a wave that surfers actually ride. Pretty cool. I think I do have a video to show you on that. Another example of an additional energy source is airborne turbines. What the heck is an airborne turbine? Well, the word airborne means that it's in the air almost permanently. It's like flying a kite in the stratosphere. Some of you may have heard of something referred to as the jet stream. The jet stream is pretty much a constant flow of fast-moving air above the tropopause where weather takes place. And it's the region of the atmosphere where jumbo jets fly in the stratosphere. Well, the jet stream is like a river of fast-moving wind high above the surface of the earth. And it's pretty much always flowing. There are a number of design ideas suggesting we could suspend these turbines, which would be like big rotating kites attached to cables, and bring them up into the stratosphere and let them turn all the time. And as they turn, there would be a generator installed on them, and the electricity would be channeled down the cable. Now, as you can imagine, these have not caught on in great popularity because you can imagine that if the jet stream winds were to die down, this big, heavy, bulky airborne turbine would fall out of the sky. And you would not want to live underneath one of these airborne turbines, if you know what I mean. Because you can imagine they'd have to be pretty heavy to generate electricity. So they're still working on some details about airborne turbines. Another example are called microgenerators. These are actually catching on. In fact, these have really caught on in underdeveloped nations of the world where there are smaller populations in regions and there is not the infrastructure that exists in more populated areas like the United States. What are microgenerators? Where microgenerators would take advantage of, say, a smaller river. And instead of damming up that river, just install a rotating microgenerator. It won't generate nearly as much electricity as a giant hydroelectric power plant that they have in the West. However, they may be more than sufficient to generate enough electricity for some small appliances in a very small community, or even here in a small single family home. They might generate enough electricity. So, microgenerators are becoming more popular in different areas. That brings us to the final one here called geothermal. Now, when you think of geothermal, you probably think of geo, earth, thermal, heat, heat from the earth. You may think of volcanoes, and that would be partly right. In fact, the whole nation of Iceland generates all of their electricity through geothermal sources. Maybe you've noticed on the news recently that there is a volcano erupting in Iceland for the first time in, I think, 800 years. However, despite the relative lack of active volcanoes, there's active volcanization taking place below the surface off the coast of Iceland, and there's active geothermal energy in the country of Iceland with geothermal vents, with hot pools. There's an enormous amount of heat energy in the nation of Iceland. And so their entire country is powered through geothermal energy. Now, here in this region of the country, and we're in New Jersey and Warren County, I'm aware of a number of people who have geothermal units on their houses. Now, we don't live on top of a volcano, nor are there geothermal vents here. But there is a constant and ready supply of geothermal energy anywhere in the earth if you dig down deep enough. Now before you misunderstand what I'm saying, I'm not suggesting we dig down to the center of the earth to unleash the enormous built up heat energy down there. No. What I am referring to is this. Perhaps some of you have visited a cave or a cavern in your life. Perhaps some of you have heard of root cellars. Perhaps some of you have basements in your homes. If you go down in the earth about 10 feet or so, the earth remains pretty much a constant 50 to 55 degree Fahrenheit temperature year round. So if it's really hot in the summertime on the surface of the earth, dig down deep enough and it's going to be really cool, relatively speaking. And the opposite, if it's really, really cold in the wintertime and you dig down deep enough in the earth, it's going to be relatively warmer because the temperature fairly deep in the earth's crust, say even just 10 to 20 feet down, remains a constant temperature year round. That fact can be utilized to help supplement heat energy in your home. Think about this. It's a really hot day in the summertime. Let's say it's 100 degrees Fahrenheit outside. Well, if you have a geothermal unit down deep enough in the Earth's crust, it's only 50 degrees Fahrenheit. That's a big difference in temperature. If you could run plumbing down there or even just extract cool air and blow it through your home, that can reduce your energy bill tremendously by cooling it off in your house. The opposite is true as well. If it's 0 degrees Fahrenheit outside of your house, but it's 50 degrees warm down deep in the ground, can bring up some of that warmer air or water if you've got plumbing through there to start heating up your home to 50 degrees Fahrenheit. And then you only have to supplement that geothermal energy by a few degrees to bring it up to room temperature. So, geothermal units, depending upon how effectively and efficiently they are built, can be a significant supplement to energy needs to people's homes. But of course, if you live on top of a volcano, your utilization of geothermal energy can be rather more significant, like in Iceland. All right, so there are some other sources of energy. I'd like to finish up today, however, with an interesting debate that ensued over power transmission. Because no matter how you generate electricity, you've got to get that energy from one place to another place. And sometimes, depending upon what type of generation station you have, it might be very many miles to transmit that electricity from one place to another. So you're going to be learning a little bit more about these two individuals, Nikola Tesla on the left and Thomas Edison on the right. You see, when electricity first started to be transmitted over distances, there was a huge debate, a powerful debate, you might say, between this newfangled technology of AC that Nikola Tesla was a fan of and DC that Edison was in favor of. Now, what do these letters stand for? Well, DC stands for direct current. You are familiar with direct current in the form of batteries. If you have a device that operates with batteries, that's direct current. It's going directly from that energy source, a battery, to the device that is utilizing it. It's a direct flow of electricity. That is unlike, however, what we call AC or alternating currents. Your home is powered with alternating current, which flip-flops back and forth between the positive and the negative very quickly at a regular rate. You plug something into an outlet, that's tapping into alternating current. Now, as I said, this difference between AC and DC was a major source of debate between Edison and Tesla. And I'm going to be linking you to a number of videos showing you the lengths that these two guys, in particular Edison, took to convince the public that their method of power transmission was better than the other person's transmission power. I will let you watch the videos and be a judge yourself to determine who you think won the current war. Bump. So make sure you tune into these videos and watch them in their entirety. So, because I'm going to be asking you questions definitely on this week's quiz regarding some of these interesting techniques and strategies of persuasion that Edison and Tesla utilized in order to try and win people over to their point of view. And you'll have to watch them to find out who won the war. So I'm going to let you turn over to those videos now as I say bye-bye.